Math Marvels, in this lesson we're going to look at 3 possible solutions when we're looking at equations, and it's based on a number. So essentially you're going to look at when we have exactly 1 solution, 0 solutions, or infinite solutions. And in our first example, we're going to look at exactly 1 solution. It's going to look like 1 exact answer. And just looking at this one here, 4x is equal to 2x plus 6. Everything we're going to do, we're going to solve. We're going to try and solve for x and simplify the problem and see what happens. You're going to notice some things. So if I was normally doing this, I know I would subtract 2x because I want to have all the variables on one side. So 2x equals 6. I like that, where a term is on one side, variables on the other. And we're going to isolate the variable to get x equals 3. This is what 1 solution looks like. Okay, you have a variable is equal to an exact number, 1 number. Nice and easy. So looking at what this looks like on our visual, all right, first thing we did was we took away 2x's from one side and 2x's from the other. And then in our math brain, we knew that 6 was equal to these 2 boxes, so we split it in half. We divided by 2 and put 3 in each box. Okay, so nice and easy. The only way this works is if each box is equal to 3. It's the only time it works. So 4 times 3, which makes 12, is equal to 2 times 3 plus 6. That is equal. 12 is equal to 12. If I put any other number, it's not going to work. So for example, if you try to put 4 in here, I'm going to put incorrect answer 4 and 4. So 4 times 4 we know is going to be 16. And on the other side, 2 times 4 is 8. 8 plus 6 is equal to 14. So here we have 16. Yeah, there's no way 14 is not equal to 16. So the only answer is ever going to work is when x is equal to 3. And that's what 1 solution is going to look like. So hit pause so you can jot it down. And remember, it's going to look like something like this, where you're going to have just 1 exact number. All right, so let's look at when we have no solution. So this one doesn't work no matter what. So I'm just going to put x plus 10. I don't want to put the 1 as a coefficient. Is equal to x plus 20. I would try to do the same thing again, moving my, trying to eliminate and put all my variables on one side, but the problem is they cancel each other out, and I'm left with 10 is equal to 20. And this is not true, Math Marvel. So if you have a case like this, where you try simplifying and you get 2 terms that are not equal to each other, then you have what's called no solution. It is not true. You may also say, but Miss, what if I moved the constant terms first? Okay, we'll try it. So x plus 10 is equal to x plus 20. Let's say you tried moving the 10. So now I'm left with x is equal to x plus 10. I still got to move this x over. And now I'm left with 0 is equal to 10. It's still not true. Like, no matter what, I'm left with a statement that is not true. So that is what it looks like. And in looking at my visual, you can see how something's wrong with this. Like, these numbers are supposed to be the same, but because my constant terms are different, there's no way I can put a number in here and it's going to make it true, because my boxes have the same number. Nothing will work. So I'm going to hit pause for a second. This is what no solution looks like. You try working through the algebra and you get a statement that is not true. So that is no solution. All right, let's look at the last one, which is the infinite solutions. So all numbers work. Every single one. Now, why does something like this happen? So here's x plus 4 is equal to x plus 4. And what's the first thing you notice Well, you notice that they are the same z's. They're the same. They're exactly the same on both sides. So no matter how I work through this problem, they're going to be the same. If I subtract 4, I have to do it to both sides. Do it one side, do it the other. I'm left with x is equal to x. This is true. But that means that any number can go in here. If x is equal to itself, then, all right, if x is equal to 8, 8 is equal to 8. If x is equal to 9, 9 is equal to 9. Like, I can put any number in and it's going to work. So it's always true. Let's say you decided, all right, what if I moved my x's first? Would it still be the same? Okay. So I take x away from one side. That means I got to do it to the other. And I'm left with 4 is equal to 4. Also true. So this is just another way of recognizing that they're absolutely the same. And in our picture, you'll probably notice it that both expressions are exactly the same. So hit pause so you can jot this one down. And let's try to put this into practice, and we're going to use raised with this problem. Let's read through the question first. What is the value of the constant h in the equation shown below that will result in an infinite number of solutions? So when I'm looking at infinite, I'm already thinking both sides have to be true. So infinite, both expressions are going to be equal to each other. This is an EE problem, and our important information is just going to be that equation. 12x plus 15 is equal to h times 4x plus 5. And we know that we want both sides to be equal to each other. So we want a to be equal to a. That's what we want, both sides to be the same. So my strategy is going to be to sub for h, see what creates infinite solutions. That's my strategy. And just looking at it, because I know I want both sides to be the same, I'm going to start by eliminating A and C. I'm going to eliminate them because those have negative terms. If I were to multiply by a negative, that would make, if I put -3 in here, that's going to make a term here negative, which means that these sides would not be equal to each other. I wouldn't have that situation. So I'm going to eliminate, and now I'm left with just 2. So let's sub in. I'm going to put the first one, 12x plus 15 is equal to h times 4x plus 5. So let's try the first one, 2. So 2 times 4x plus 5. And that's going to give me 8x plus 5. So just by looking at it, I don't think this is going to work. This is not what I'm looking for, because just looking at it here and here, they are not the same. They're not equivalent to each other, so I don't think it's going to work out. But I'll go through the entire process just to make sure. I'm going to subtract 8x. I'm going to subtract 8x. And I'm left with 4x plus 15 is equal to 5. I'm going to subtract 15 and 15. And I'm left with 4x is equal to -10. See, this one's not working. This will give me one solution when I work it out. I'm going to divide by 4, and I'm left with x is equal to negative, let's see, 10 divided by 4 is 2.5. So -2 and 1/2. So this will give me one solution. That's not what I'm looking for. I'm looking for infinite solutions. So 2 does not work. Let's try the last one just to see. And I want to give some space. And I'm going to do the same thing. 12x plus 15 is equal to, I'm going to sub in 3 times 4x plus 5. So I'm going to distribute, and I get 12x plus 15. Boom! What do you see, Math Marvels? They're exactly the same. So this is already an absolutely true statement. This is going to give me infinite solutions because this is exactly equal to this. So I'm going to circle this one. Now, if you want to carry it all the way through to make sure, you can. So I'm going to just subtract 15 on both sides. And now I have 12x is equal to 12x. So you can already see, again, same. I'm going to divide both sides by 12. Now I'm left with x is equal to x. And this is infinite solutions. Hit pause so you can jot this down. All right, let's determine the number of solutions for this equation. So what are they asking for? Is there one solution, infinite, or no solutions? Our only fact is the equation that was listed above. So my plan is going to be to simplify both expressions. In this case, that means I have to distribute first. And I'm going to use my algebra to really solve for x. And I'm going to use my answer once I simplify it all the way down to determine the number of solutions. Is x going to be equal to one number, one solution? Is x going to be equal to x, infinite solutions? Or am I going to get a statement that is absolutely not true, no matter what I put in, or no solutions? So hit pause so you can jot this down in your notes and we'll put our plan into action. All right, let's start simplifying. I'm going to distribute first. And on my left, I get negative 10 over 5x plus 5 is equal to negative 2x plus 10. I'm just using my conventions here. Negative 2 times a negative 5 is positive 10. Let's work with that fraction. Negative 10 over 5. 10 divided by 5 is 2. So negative 2x plus 5 is equal to negative 2x plus 10. What do you see? What do you notice? Already you can see they're very similar. They both have negative 2x's on both sides. So I'm already leaning towards there's no solution here. That they're not going to be the same. And if I try simplifying them, I'm not going to get a true statement. So I'm going to move forward. And I'm going to add 2x to make a zero pair here, just 5. That means on the other side, I'm going to add 2x. And I get 10 on the other side. So as you can see, this is not true. Not a true statement. 5 cannot equal 10. So this means there are no solutions. So hit pause and jot this down into your notes, math marbles. Remember, as you're simplifying through your answers, you're going to look to see if x is equal to exactly whatever your variable is. As long as it's equal to some number, it has one solution. If you end up getting x is equal to x, the same exact term on both sides, or the same exact variable size, that is our infinite solutions. And if you get a statement where two numbers are absolutely not equal to each other, then we get 0 solutions. So hopefully with practice this will make more sense. We'll do a lot more problems like this later in the year, but we're going to pause here. I will see you in the next lesson, Math Marbles. Let's get some practice in. I'll see you next time.